Good morning. Hello. This is Mike working yet? Mike, hello. Okay, there we are. Hello, everyone. This is the Ietf 120 meeting of the Quic working group. If that's not where you intended to be, you can stay. But I would ask that everyone, whether you intend to be here or not, use the on-site tool to record our attendance, since otherwise it doesn't count. And this is also how you will join the queue. So please do that. So now starting off, this is the note well. It's late in the week, but we're going to talk about it because you never know when people haven't seen it before. But this is the rules and policies under which we all conduct at the Ietf. And so please read it if you have not, and consider this and also the code of conduct and the anti-harassment procedures, since these are all taken pretty seriously here. And so we would like everyone to be aware of them. So meeting tips, you probably know this by this point in the week, but you can use the on-site tool. It's really important that you get in the queue. And if we run any polls, that will also be done through that tool. If you are remote, it's the same thing, except for you obviously have the audio and video, and keep it muted. And yes. All right, Administrivia, everyone's favorite. We need a note taker. We are not able to have minutes unless we have somebody who volunteers to take notes, and we've already got Martin Duke. Thank you, Martin. Do you think do you anticipate needing a backup at any point? Yeah, so does anyone want to back up? Martin's usually very good. Okay, thank you. All right, we've got people. I appreciate this. And so chats, we will be using MeetEcho/Zulip, and if somebody is in the chat and wants something there for the mic, please try to get our attention, and we'll try to convey that question. The queue itself, we will run the queue. You can remove yourself if you want, but I will kick you out anyway if you forget. So up to you. Agenda. So as usual, we start with our adopted working group items. In this case, we have substantial time dedicated to multipath Quic, and then we have some more time dedicated to QLog. And then following that, assuming we have time, we will have other items, and that's accurate ECN. We're going to have a quick mention for H3 priorities and a fun topic about Quic tokens. Is there anyone who wants to bash this agenda or otherwise recommend changes or other things? Okay, seeing nothing, moving on. So these are some general notes. We are looking for implementers for some of our documents. Specifically, ACT frequency and reliable reset have both successfully concluded our working group last call, which is great. But there's a sense that we need some more implementation experience before progressing these documents. So if you are an implementer or you use an implementation and you're interested in these features, we would greatly appreciate that you spend some time implementing them and reporting what you find to the list, because as of right now, we think that there needs to be a little bit more before bringing these documents forward. So some more sort of in administrivia, we had a 3GPP liaison request. This was basically asking, why are your security considerations blank in this document? That's scary. And we have a response that we will show a little bit. Let me put it up, which is basically, yes, they were blank, but they have been populated, and please give feedback to them. So this is this response we sent to 3GPP. If you're interested, this is recorded on the data tracker. So yeah, and to talk about the hackathon, I'm going to pass it over to Lucas.
Hello. Yes, I'm a bit poorly, everyone, so I'm sorry I'm not in the room. Oh, my voice is weird. Yeah, I just wanted to do a quick kind of view at the hackathon. We'll hear directly from the multipath Quic folks about the interop there. That's a working group activity, and we do discuss those in this thing, but there's other work that's happening that's Quic adjacent, and sometimes unless you're directly involved in that work, maybe you're missing out. So I just want to give a kind of a quick shout out to those pieces of work too, and to ask people to get in touch, especially if they're more thinking from a quick implemented perspective or very much still focus on the transport layer, to raise awareness for these other work that's going on. So at the hackathon specifically, there were tables on meter over Quic and RTP over Quic, including some work on QLog that we did. There was work on a lightweight Quic for OpenThread. I'm not quite sure how that went down. I didn't get to see the presentation talks at the end either. So if anyone would like to speak to that, that would be fantastic. I had Mark's work on quick profiling for deep space. We had Reese championing testing congestion control algorithms. That's not just Quic, but some of the explicit work being done there was for Quic. And there were some interesting results presented for a specific extension to Quic. Both at the hackathon and in TSVWG, I believe. There's something I was working on, which was HB3 low-level testing. I'll follow up on that somewhere, but that's some open source code to help some things. Less so specifically about Quic, but whatever. But we also had some work going on Quic on streams. If you recall, we discussed that last time in the meeting, at the Quic working group meeting. We won't be discussing that this time. But there are still people busy hacking. And so the Quic Go implementation had a contribution to add it there, and there was interop with Kazuaho's Quickly stack. So those kinds of things can help inform future discussions at these meetings. So I would encourage people, even if there isn't adopted working happening in this group, to just participate. That's all, thanks.
Okay, and with that, I think we are moving on to our first slides, which are the multipath. Yanmei, you could either try to do the control yourself or just tell me when to move them.
Yeah. So can people hear me?
Yes.
Oh, yeah, good. So let's start. So I'm Mia, and today Mia and I will introduce about the multipath extension updates and the left issues. Yeah, first I will give a brief summary about the changes from draft 06 to draft 10, and also about the hackathon reports for draft 10. And Mia will introduce about the open issues and the pull requests which need discussion. Yeah, next slide, please. So first about the draft 07 and the draft 08. First of all, we have merged the explicit pass ID proposal from the last Ietf. We have a draw conclusion about that. And then we have a clarification that the both endpoints should use the same pass ID from both sides. And about the max passes frame and the pass abandon frames, we changed them later in draft 09. So I would like to introduce them in the next page. So next slide, please. Yeah. So from the last Ietf, we have an interim meeting about the draft 09. Actually, we have drawn a conclusion from the interim meeting that we can use the value for initial max pass ID instead of the max pass counts for the transport parameter. So we have done the update, and also we have changed the max pass ID frame for the same semantics. And I'd like to thank Martin Thompson for pointing out this idea and also helped update the pull requests and help review the last version. So big thanks to him. Yeah, and also we rewrite the pass closure section. Endpoint should send pass abandon frames in each scenario as a signal for the pass closure, and also endpoints don't necessarily need to send the MP retire CID for CIDs belonging to this pass. And also we add recommendations to use the pass ID continuously. And also we have other editorial changes. And yeah, we have the first update for the security consideration section about the potential attacks and how to prevent them. Yeah, next slide, please. About the updates for draft 10, yeah, most changes are more editorial changes. We specify the details for the MP retile connection ID frame, and we also rename the ACK MP frame to MP ACK, but we don't change the semantic. And also, we allow the multiple passes to use the same for turbo. And about the limitation for initial max pass ID, is for the security consideration for the AED, the encryption and decryption. And also we have more guidance on the pass status. So other changes are both minor editorial changes. So next slide, please. Yeah, and then we come to the hackathon. This time we have 3 clients and 4 servers participate in this time's hackathon for draft 10. And we have 11 cases. This time we add a CID retirement case and also migration case for this time's hackathon. We have drawn a nearly full table for this time's hackathon, so I would like to say that everyone is doing a great job. Yeah, so thanks for all your efforts. So next slide, please. So I think the next part is for the issues, so I'd like to switch the micro to Mia.
Do we have a mic at the front that's not this mic? Is that mic on?
Now? Okay. Yes, hi, my name is Mia Kuleman. First of all, for the updates we did, I want to say thank you for everybody who opened issues, provided feedback. The one thing that we didn't update is the acknowledgement sections. We will do that and put your name in there. Thank you anyway. We have made like a huge amount of progress. I don't think we have like any big issues anymore. So what we will try to do is go through the remaining issues which might have some kind of design implications. And I think we have like something like 13 or 15 issues. And our hope is if we can run through all of them today quickly, then we are only left with like smaller editorial stuff and we're actually on a good path here. So let's start. It's really weird to stand behind this thing here, but okay. Okay, this is supposed to be an easy one, so let's make it easy, hopefully. We've been thinking about renaming the frames because they have been named inconsistently, and this is, you know, we can roll a dice or whatever, but we have to decide something. So the proposal was actually to, instead of using MP for everything, we actually just use pass, which is kind of more aligned with what we already have in RFC 9000. So anybody has opinions about this, or should we actually roll a dice? To rename? Was this a yes to rename or? Okay, yes. Okay. Okay. Easy, next.
Isn't max so-and-so more in line with RFC 9000?
Sorry, say it again.
Isn't max so-and-so from a max path ID? Doesn't that line up better with RFC 9000 names? Or am I forgetting something?
I don't care.
Yeah.
Did you have a similar comment, Christian? Yes. Maybe add it to the GitHub issue, and then if other people have comments, you can have it, but we definitely rename it. Okay. Then next. This is also about naming. So this issue was a longer discussion, and the original issue was you now can actually already a few versions ago you can actually send pass status frames. So there's a pass standby or also pass available for passes that are not actively open yet. So you have issued connection IDs belonging to a pass ID, and you can provide a status frame for those even they are not used yet then. And that can be confusing because that means the other end, has to pick some of them and then has to accept whatever the status is, but you can also update the status at any time. The use case is a little bit, for example, if you want to guarantee that you have only one available pass and everybody else, every other pass is in standby, you can only issue new pass IDs that are in standby, and so you can guarantee there's only one available pass that is like the preferred one. That's, for example, the use case. But the whole point is it gives like some flexibility, and that's probably all fine. The long discussion on the issue ended into something saying actually pass standby is really confusing. We should name it pass backup. So we can do that. Yeah, really excitement here. Any thumbs up? Yes, okay, let's do it next. Okay, that was like the warm-up, and now we see if we have like more interest here. Okay, this one should also be easy. So there was an issue opened by Mike Bishop, I think, saying the preferred address is not very clear. So we have a new PR there that is trying to clarify this. And what the new PR says is that if you have disabled active migration, that means you're not allowed to actively migrate on the path that uses the initial local address from the peer, but you're still allowed to open a new path, and you're also then can migrate on that path and use migration, or you can migrate on any other path. So I think this is in line with what the original use case for this is, which is like you send something to an Anycast address and then you want to move it over to a real address. So that is only kind of a line that only is important for like the initial address you're using for sending that, but not for any additional addresses that you might use to open a new path. So that's kind of what we clarify, but we wanted to double check that this is like the only use case and that's the right thing to do. So the PR is ready and we can merge it, I think.
Christian Wittemer. Yeah, I think that issue is indicative of something that we are doing that is maybe not explicit, is that the multipath extensions are pretty much taking over the path migration that was in 9000. And the disable active migration was actually linked to the old way of doing migration. In multipath, you can only do migration if the peer has given you permission to open new paths explicitly by providing path IDs. So I think that we may have something there which is still in how much do we keep of 9000 and how much do we jettison.
I mean, you can also only do migration in 9000 if you have a connection ID that you can actually migrate to. So it's like not that different in that sense. Yeah. But I think there is definitely a point about being more clear about what's migration, which means changing something on one path, and what's like actually multipath, which means opening another path. And yes. I think we can be actually editorial more clear about this in the draft as well.
Yeah, and so basically, I think the conclusion that we don't do migration on path 0, if there is that, is cool. And if the peer wants to prevent migration on path 0 and yet allows you to open path 1, that's what he said.
Yep.
Yeah.
Okay, perfect. Good. Next one. So this is one of the design issues that is open for quite a while, and I'm not sure we have like full agreement, but here's the proposal. So the question is, should we use the multipath specific, should we put a should in, a normative should, to use the multipath specific egg? And I think this also applies to like multipath specific connection ID management for path 0. And should we recommend to use also these frames for path 0, or we could also use the old ones from RFC 9000 for path 0. There was a bunch of discussion here. some people say they want a must because they don't want to implement the old ones anymore. However, you need them still kind of in the handshake. Others say this should be rather a may because there's actually benefit of using the old ones for pass 0 because that saves you a byte. And so at the end, I think we just keep the should and everybody does the right thing, hopefully. So that's the proposal. Yes.
Kazuho, so my weak preference is doing must because in the application packet number space, we can always use one form, and that's probably more consistent in my view, though that's not a strong opinion. I wouldn't mind if people think otherwise.
Does anybody have a strong opinion? I think Jan Mai, you were kind of more on the May side, right? Do you want to speak up?
Yeah.
Now we can hear. Yes.
Actually, I don't have a strong point on the ACKMP frames, but I do think that for the CID retirement and the new CID frames, the initial pass could use the frames from IFC 9000, so it would be more compatible. But for the ACKMP frames, I don't have a strong opinion on that.
Okay, so I think if nobody has a strong opinion, we just stay with the should. There we are. Christian?
Mike, I think first.
Okay.
Yeah, I mean, you have to handle the legacy frames during the handshake, so I don't think there is a good argument for must to prohibit them later. So if either type is acceptable, we can give guidance with a should. We can just say may and let implementations work it out. It doesn't really matter so long as if we agree we have to be able to support both, then should or may is the same. It's just what applications decide to do.
Christian Uitema, I think it's tied to what we can do before the handshake is complete. And if we are very clear that we are never going to use the new frames in 0 RTT packets, then we can have a must because there is no situation in which you can send one RTT packet and you don't know the state of the negotiation.
Yeah, it could be a must. It's just a question if it's useful.
And the value I see with the must is that it's one less code pass in many of the code. And one less code pass means you don't have to do 2 series of tests instead of just one, etc., etc. It makes the verification of the code simpler.
I mean, does it really? Because you still need to support RFC 9000, right? So.
No, it's basically once you have negotiated multipass, you can have basically a code pass that says, if I have negotiated multipass, I only do this. And you can have another way of doing that is, if I have negotiated multipass, I do this or I do that. So
that means if you negotiate multipass, you have a must, you actually ignore the RFC 9000X and...
Either ignored. If you have a must, then it's not an ignore, it's a protocol violation.
But then you need also pass for that, right? You have to detect it and then
but it's basically, it's easier to test. It's easier to test and you have to write fewer tests. So
I have no opinion at all. Chairs?
I don't think that, I mean, Christian makes a point, which is that maybe this is slightly easier for an implementation to handle if there's a must there, but it doesn't sound like the group. Is anyone else who's implementing this have that same opinion, or is this is that going to help implementation significantly? I will remind you that a must obviously does not really make it so that everyone will do it, so you'll have to write code that then detects it and all that. But so.
It's basically the same point Kazuo was making. Mm-hmm. It's a weak preference because it does make your code a little bit easier. But you can tell me it's just code. We can do that, right?
Is anyone opposed to a must that is maybe slightly qualified and reminds that, you have to have it for the handshake? It sounds like we just don't care for the most part.
And I don't think the argument for a must makes much sense, but I think it's fine. Nobody's going to die on this hill, I think.
Quentin?
Yeah, just to give my 2 cents. In my implementing both is quite simple. So actually, I can keep it as should. I think it's fine. But I would prefer avoid having a must because we need to support ACK and MPAC anyway.
Wait, so just to be clear, that was prefer a must? I didn't quite catch that. Okay. It sounds like people would not oppose a must and some people would like it, so I'm kind of inclined for a must at this point. That's kind of the sense I'm getting.
Do we want to vote, or is it?
Do we want to vote? I guess we can make a poll, but
Actually, can you do it so we have it on record?
yeah,
It's
okay.
fine.
We will make a show of hands for this, which is going to be. Let me look at the title. Martin Seaman is in the queue, and he just walked in the room. So.
Yes, as a point of reference, the reset stream ad has the same problem. And we decided that we can use both frames there. So my weak preference is a should or may.
When you say we decided, can you remind me if the working group decided that and we had this same bike shed there, or did we not?
No, this was this working group.
Yeah, no, I know, but did we have was that in this room and we had like the same sort of?
Yeah, so the reset stream ad has an offset field, right?
Yeah.
And in the case where the offset is 0, it's equivalent to the RFC 9000 reset stream frame. And we said we can use both.
Okay, well, I'm going to do a show of hands just because,
Yeah, just because votes are so much fun, and then we have it on record. And to make you all wake up. So also maybe just to confirm, if we do a must, that means if you receive one of the old frames, this is a protocol error. You have to close the connection, okay? Yeah. Okay.
Okay, so I have made the show of hands, even though I could not see what I was typing. So this is yes, no for must. Because I did not want to put should in the must question, so.
Great. Oh, yes, it's catching up, okay.
I'm disappointed in the bike shedding here. So we're trending towards random.org deciding here. Okay, so that was conclusively inconclusive. And I think we're just going to have to pick one. So
Should, yeah.
we keep should?
Yeah.
Okay, well, all right, then I guess we're going to have it be should. But yeah, so we'll move on from that one.
So yeah, we can add a little bit more guidance about why this is should and when it's useful or not useful, whatever. if somebody wants to write text, but yeah. Okay. Next. So we merged already PR 400, which now says you can, or like which removes the restriction that you can only have one pass on a for tuple, because that restriction is simply just not needed anymore with the explicit pass ID. However, there might still be use cases where one of the endpoints maybe only wants to have one path on one for tuple, and then an endpoint could decide to just close the path. It's easy. But the only problem is, like, if both of the endpoints decide to close different passes, you might not have any pass anymore. But maybe that's not our problem. So the only question is, should we give any more guidance on any more discussion about that? The other one is a little bit related to congestion control. If you're using multiple paths on the same for tuple, then it's usually the same path, the same like link or whatever. Could be, doesn't have to be. Should we say something about congestion control? So as I said, this is already merged in. You can use multiple paths over the same for tuple, but should we say more is the question. Magnus.
Yes, I think one reason I see for using the same for tuple potentially is to actually have different code points, and then you actually have the separation that they are two routing while running treatment-wise they're two different paths, even if they're on the same for tuple. So I think that is one reason where one might have to be a little bit careful here.
And do you think we should talk about this in the draft, or we just don't need to say anything about it?
I think it's worth mentioning as a reason why different endpoints can have different views if they try to do something like that, because that's not explicit until you actually see packets over the path, and if you're looking at the DHCP code point.
Watson Lad, Akamai. I think we should add what Magnus suggested, because when I came up here, my response is going to be, why would you do this? And now hearing the reason one might want to do it, I think it's worth putting in just to avoid the reader having the same initial reaction I did.
Alessandro Ghedini, Cloudflare. I don't quite understand what the further guidance would be, though. Like, do you just say, don't do this? But then there's no way for, like, don't try to close the two paths at the same time, but then there's no way.
Yes, so, I mean, like, you could try to deconflict this, like, formally or whatever. I think the minimum we could say is, for example, if, like, the other end opens a second path on the same tuple, rather close, like, either the old one or the new one. So, you know, there's, like, some kind of guidance.
Okay. Yeah, I think we should write this deconflicting rule, but we have to remember why people do that. And typically, the reason people will do that is because the for tuples doesn't describe entirely what's happening on the path. You have also things like the IPv6 flow ID, maybe the quality of service thing. You might have some local preferences. So, so it's not clear. For example, if you have open one path with a flow ID 0 and no QoS, and the other path with some definite flow ID and some QoS, I mean, they're not equivalent.
Yep.
So it's pretty hard to give definitive guidance, say you shall always close number 1 or number 2.
Do you anyway want to try to write something? Christian?
I guess I will write something like just what I just said is basically you have to understand why you're doing something.
Okay. But it definitely sounds like people want more guidance, so we will work on it.
Gori.
Yeah, Gori. SRv6 and other things as well, which means that the same for tuple isn't necessarily the same for tuple. I mean, I don't think we have to go overboard here. This is just kind of pointing out that there are other things apart from that for tuple which can make separate flows.
I mean, the other kind of guidance could be if the other end opens more than one pass on the same tuple, don't close anything, please. Right.
Right, just wanted to say what others said, and with my example being the quick aware multipassing doing the correlating the port numbers.
Okay, next. Okay, error codes, yes. So the question that was like, I think we changed this a few times, but we still have like 4 cases where we use error codes, and we use 3 different ones. We have a multipass specific protocol violation. We have transport parameter, frame encoding. So I think like using the ones from RFC 9000, we got straight now, but the open question was still, do we need this like multipass specific protocol violation, or can we just remove it and use the normal RFC 9000 one? Or alternatively, in this case, in the first case that it lists here, where like you try to negotiate multipass, but you don't put a connection ID in, which like doesn't work, do we want to have an even more specific error code for this case so you can detect it quickly? So that's the 2 options, 3 options actually. Do nothing, remove the multipass specific error code, or define a new one.
Alessandro Guidini, Cloudflare. So I guess the benefit of having a specific error code is for debugging maybe, but then I don't know that this specific one is actually that useful in practice. So we can, I don't care that much, but if we remove it, that would be fine.
I see Kasu nodding. Then we just remove it. Okay.
Just a quick question. Do we know how many cases there are in the document that would result in a protocol violation? There's 2. Okay. So it's okay. So from a debugging standpoint, it would not narrow it down a ton. Okay.
Okay. Martin.
Martin, do Google. I mean, I don't care that much. I'm not implementing it, but like we have 2 to the 62 error codes. So like, if there's any possible scenario where like, you know, you're debugging problems and it turns out there's something, this is for RC 9000 violation versus something that's actually related to the new stuff that we're debugging, that strikes me as useful. But again, I'm not an implementer. I don't care that much, but like, why not have more?
Well, the reason for why not have more error code is basically a trade-off between debugging and enabling attacks. If you are, say, writing a fuzzer against somebody's implementation, the more error code you have, the better it is, because now you know what kind of area in your target's code is buggy. So you have always that trade-off. I don't think that having a MP protocol violation is a big issue, but I also don't think that we should have fine-grained error codes. If you want to enable debugging, you always have the possibility to use error phrases, sentences, as comment of your error code during debugging. And you can remove that when you're not debugging.
If I could briefly respond out of queue. Yes, that's convincing. Thank you. I withdraw my comment.
Okay. So we remove it. Perfect. Next.
Mike, do you still want to say something?
Oh, sorry.
I was just going to point out that we do have a connection ID limit error in RFC 9000. So I could see having the equivalent path ID limit error, but we can also just use that, have MP protocol violation. I think Christian's comment is convincing for why we might not want to, and that's fine.
Okay, I think we still remove it. Okay, this is also related. This is the pass abandon frame that we newly defined in this document. It has an error code, and we don't say much about this error code. And the question is, should we use the application protocol error codes? And yeah, what should we say here actually? I think this was your proposal, Christian, right? To use the application protocol error codes.
Lucas.
I don't understand why this would be an application error. So why would I use application codes?
Because it's closing a path, right? So that's usually an application action.
Oh, sorry. The application codes are for the application mappings. So something related to HTTP3, for an example. An error in the application layer's additional framing on top of Quic, for example. On top of that, you would have your own application layer signaling, such as status codes or other things. Yes, the action of abandoning a path might be powered by an application, but I don't see any reason we would use those codes myself.
Christian Uitema. So yeah, because we discussed that, and the discussion is that basically we could, in theory, split the abandoned frame, the path abandoned, as path abandoned by the network, path abandoned by the application. The same way the connection close as a bit in the frame type that says by the network, by the application. However, there are very few cases in which we have a network reason, a protocol stack reason to use the close by the transport rather than close by the application. And I think it's simpler to say the response code is always chosen by the application unless it is 0. And if it is 0, it can be used by the stack as well.
Speaking as an individual in the queue. So Christian, are you suggesting basically that a hypothetical MP Quic specific application would define, for example, I'm giving up on this path and I want to tell my peer application that I've done that. And that would be encoded in this frame, similar to like how an application level close would be used, or an application level stream error?
Yes.
Kazuha?
Kazuhoka, I could be wrong, but if I understand correctly, all the number space of application protocol error codes are reserved by the application. So if we say that this field carries an application protocol error code, then we would essentially be forbidding the transport layer to send this frame.
No,
because zero isn't, we can reserve 0 on any number. So I think the question is if you want to go that path or not.
Yeah, I'm still speaking as an individual. I should have clarified the first time around. I think this is going to cause issues because right now I can kind of port my HTTP3 app to use multipath without any changes to my HTTP3 application mapping. Whereas this seems to make me feel like I need to now describe how all of the error codes map to some path-related things, and that what the client or the server need to expect if they receive this frame, and if they need to bubble this up to their equivalent receiving peer. It just sounds like it's going to open a can of worms to me, and I don't see the benefit in the first place.
So would it be okay to just maybe remove the error code at all? Yeah, okay.
That was actually going to be my suggestion. I can't think of any existing error code in H3 that would be the reason why we closed a path. Either we're going to close the stream or the connection, but paths aren't really affected by the things that are happening at the application data layer, other than maybe exchanging what your endpoints are. So it seems to me that debugging is the only reason for the error code. So maybe we might want to leave the reason phrase, but I don't think this is going to carry much value most of the time in production.
Do we still have it?
No, I wasn't sure if Martin was doing. So, Christian, so do you think that this is required for like for multi-path applications to have success, or could this sort of semantic of a application that has a application reason to abandon a path, could that be added later, or do you think we need this in the base spec?
I'm kind of convinced by what I heard in the discussion.
Okay.
It says, well, right now the application doesn't actually want to provide a reason and want probably to delegate that always to the protocol stack, in which case the protocol stack will use existing protocol errors, like no error is just normal thing, or maybe it's out of resource, maybe it's something that's fine.
Okay.
So basically that means there is no ambiguity. I mean, the first priority is that there is no ambiguity. And we say this error code is defined as a quick error code. It's not an application code.
Or no error code at all?
I can see a difference between no error and I just ran out of resource, which exists, I mean, internal error.
Yeah, not as an implementer of MB-Quick, but just quickly saying, like, it almost feels like it's similar to, like, you would have connection close type things that aren't fatal to the entire MP-Quick connection, like, oh, my socket became junk. And I don't want to, I still have the good ones, but I'm abandoning this path for that reason.
Yes.
And that could be useful to know.
Yeah, but I mean, yeah.
But do you need to have standardized error codes, or so if it's for debugging, the reason phrase would be enough, right? Do you think it's useful to have it in a normal running?
I mean, that's
quick
basically
connection?
what I said before. It's, I mean, error code are there to help you do debugging.
But then use the
So,
reason phrase.
so basically, you either want to have some of it or not. And well, we could have no error and no phrase, and the phrase is simpler. I am not sure that. I mean, all the equivalent frames like stream reset or connection close do have an error code to explain why you do that.
So what would be the error codes? One is like no error, and the other one is out of memory or whatever. I don't know even what the
Well,
cases are.
there's definitely no error and there's definitely out of resource, I mean, internal error.
There's another case, again, jumping slightly, but like the thing I'm thinking of is like, let's say your peer is repeatedly encountering a certain kind of error on this socket and is kind of, you could use that potentially as a signal of like, oh, maybe I should stop establishing this path because they keep abandoning it for some reason. And that could be encoded in an error code, whereas putting that in a reason is not semantic. So if you're having trouble with a socket, it's not exactly resources, but it's like,
But you can always retire basically path IDs and not issue new ones, so you can stop the other end from opening new paths.
Right, this would be more like advisory. You're saying, yeah.
Yeah. Okay, I think what we have decided is that it's definitely, if there is an error code, it's definitely a quick error code.
Yeah. Let's see what Martin has to say.
I think having, having a reason phrase feels a little bit heavy for this frame. We don't have a reason phrase for reset streams, and there's a bunch of validation logic I would need to do in my stack to actually support a reason phrase. Like I need to make sure that that the length doesn't overflow the packet, and what do I do if it's not a valid UTF-8? Like there's a bunch of corner cases. We have those for connection close, but for connection close you don't care because the connection is closed. So I'm wondering if we can get away with just having an error code, and we can have a separate error code space that's independent from application errors and existing quick errors. And then we can just define a few values. One of them could be the application asked me to close this path, and the other one is like the interface is unstable, and I'm sure we can add a bunch more.
Okay, works for me. Anybody wants to keep the reason phrase? No? Okay. This one was proposed by Mike Bischoff to add a new frame, max pass blocked. So this is kind of modeled after also how we handle streams in RC 9000. And currently we say basically implicit, if you increase the pass limit, that's also implicitly a signal to the other end that you probably want to have more pass IDs. And this one is like an explicit signal to actually provide this information to the other end. We have a PR ready to be merged, but we want to confirm that the group wants to add another frame. Martin.
Frame sounds good to me, but can we change the name to path blocked instead of a max path blocked? It's streams blocked and not max streams blocked in 9000.
I think we can. Yeah. Okay, nice. Next. So pass standby and pass available have a sequence number, and in this case, it's a per pass sequence number. So if you're using them for a certain pass ID and you send a new one, or for this pass ID, you have to increase the sequence number. For retiring and issuing connection IDs, we actually use the sequence number globally for the whole connection. And here we use it per pass, which is fine, but we could do one or the other for any of these. So there is a PR out there that proposes to instead use like a connection-wide sequence number. So no matter on which pass you're sending a pass standby or pass available, you increase the sequence number. The only difference really is it's like kind of who has to check to which pass it belongs, is it the sender or the receiver? Yeah, so both are good solutions. It's like a matter of taste. We just have to decide.
Alessandro Ghedini, Cloudflare. I don't see that much benefit in doing this. I'd rather keep the text as is.
Okay, changing it. Yep.
I mean, not changing it. Like,
yep.
It doesn't seem like it makes that much of a difference, and I'd rather not, you know.
Yep.
Kazuhoka, I prefer having consistency among how number spaces are being allocated. Either all of them should be per connection, or all of them should preferably be per pass, if possible.
So that means we would need to change that one, because I don't think we want to change the other one.
Yeah.
Yes. Okay, now.
Correct me if I'm wrong, but these are only ever processed in the context of a given path. So it seems like you could implement it either way you want. And so long as they are monotonically increasing within a path, and it doesn't matter if you skip any, so long as they increase. It also doesn't matter if they repeat, so long as they don't repeat on the same path. I'm not sure that we need to specify this so precisely how you implement it.
No, I think you have, like, it's either the sender has to, like, either you have to like a global number and you have to increase it all the time, or you can use the same number for different paths, right? So like you have to say something.
I think if you say that, then that it can, if it has to increase per path, and someone wants to have a global number, it will still be compliant.
That's true.
So I feel like maybe we don't want to overspecify that.
Yeah, maybe that's a good reason to keep it as it is. Okay, no change, I think, is a decision. Okay, so this is an issue about the tokens. So I crossed this out because I think we already agreed there's no violation of RC 9000. But currently what we say is that this is the text in the current draft, is that if a server issues a token, it might be used to validate any of the passes. So effectively, you get a token. You don't really know which pass this token belongs to, but you can use it next time, and it might either work or it might not work. But that's life anyway. So you get a token, and it might not work, no matter what. But the only question is, like, should we actually remove this ambiguity and say it has to be validating all the passes, and you can use it in any of the addresses? I mean, it might still not work, right? Something has changed and then it doesn't work.
Yeah.
But Mike.
I don't think we want to mandate what the server must put in there. Just say that the client should use the most recent one, and it probably should validate all your addresses so far, but nothing breaks if it doesn't.
Okay, so effectively we could give more strong guidance that in best case it applies to all the paths. Okay, that's then a small editorial PR thing. We can do that. So this one has a PR. There was a very short section on which was called refusing a path. It basically says kind of it did say if you don't want to open new paths, don't reply to a path challenge. We since then changed the whole idea about how we close paths a little bit, because we say effectively, because we multipath, we always have still one active path. So it's always better to be explicit about closing a path. So if you get a timeout, we now recommend you send a path abandon, or we actually require to send a path abandon. And if you want to refuse a path, even so like from your side, the path doesn't exist yet, you should still abandon this path to make sure the other end understands that it cannot use this path ID anymore, and it's gone and you will not do anything about it. It's always better to be explicit, and you can be explicit because you have an active path where you can just send these signals. So what this PR does is just removing this section and just incorporating some text in the closure section saying you also have to send path abandon frames for passes which are just to be opened and you don't want to have them. Any concerns about that? Perfect. Next. Okay, so that is, the next one is also related to path closure, and that's exactly this thing, what to do on idle timeout. So the part that we decided already is that even on an idle timeout, you shouldn't send a path abandon. But the question is, if you get an idle timeout, do you actually have to close the path? Or like, is the idle timeout even useful in multipath? Because in multipath, you very often have the scenario where you open like your backup or standby path and you're not using it, and you're just having it there in case you need it later because the other path is breaking. And of course, you can send keep alives on that path, but especially on mobile networks, waking up the radio and so on, to send keep alives might be a big barrier. So, and then if you don't do anything with this path, it will actually idle out. And then currently we say you should not use that path anymore. But effectively, there's no reason to not use that path anymore. Of course, it might not work anymore. You have to test it. But like you also don't need to close it. And so we have to probably just change this should to a may here, or not use normative language, and maybe provide a little bit more explanation if that's okay for everybody. Alessandro.
Alessandro Ghedini, Cloudflare. I mean, either you say, you know, after idle timeout, you must not use the path, or you have to do path abandon. Like, you can't do both, right? You can't have the applications just try to guess which one to use. So either you have to do path abandon, or you have to not use the path after the timeout. You can't just say, you know, you may send path abandon, because then the other side doesn't know.
So the thing is, like, if you want to close the path, if you decide there's the idle timeout and you haven't used the path and it's not useful anymore, you don't want to use it in future anymore, then you should close it and then you should send a path abandon, right? But if you get an idle timeout because you're not sending in a path, but you actually think this is still a useful path and you want to use it later in case the other path breaks, then you should not close the path and you should not send a path abandon.
So then what is the point of idle timeout for the, so if you're still going to, you know, abandon explicitly?
So I think the idle timeout, first of all, it's just there, but it might also still be useful to understand like what the state your path is in. Like if you are before the idle timeout, then it's probably you can just switch over immediately. If you are past the idle timeout, then maybe the risk that the path is broken is a little bit higher or whatever, and maybe you want to like be more careful about using it or whatever. I don't know. Or we just remove the idle timeout. Yes, we can also do that.
I think, so the point of the idle timeout in Quic v1 is so that you can close the connection silently and automatically if you don't have anything else to say from either side. So I think there's value in the entire connection being able to idle out.
Yes.
So we need it for that.
You need a
I
connection.
I think something that says if all paths have reached their idle timeout, the connection is closed.
Yes.
We need that.
Yes, true.
I don't think we need anything that says if a particular path reaches its idle timeout, you must do something. If you decide to close a path because it's idle, you should include a path abandon the next time you're going to send a packet. I don't think you should start up to send the path abandon, because then you reset the idle timeout on a different path just to say, hey, this other path was idle.
Okay, so yeah, there's actually two cases. One is like you have already a path where you're actively sending data and then you can send it immediately. And then the other case is you have like only paths where you're not sending anything at the moment, and then you should not just wake up the path for the
Right.
abandon. Yeah, that makes sense.
We shouldn't wake up to send a path abandon. If you're going to close the path, queue it to go out in your next packet.
What Mike said, but which is clear, is that we all agree that if you decide to not listen to a path anymore, you must tell that to the other peer. You may take your time to tell it. I mean, the consideration about not starting the video are great, but you must tell it. The question we had was not so much the must tell it, but that was it, not ambiguous. Everybody agreed that if you close something, you must tell the other guy. That's clear. The ambiguity was if the peer knows that you are doing timing on path, and the peer wants to make sure the path is still available, the peer is going to send bubbles on the path to make sure it's still there. It will send those bubbles at some interval that is chosen by various algorithms. The question was, do we want to have a mean to say, hey, if that path does not see any activity in 49 seconds, I am going to close it. Because if we say that the number is 49 and not 42, then that means that the peer has to make sure that he sends the bubble more than once a minute. So basically, do we want to help people implement these keep alives in a coordinated way?
So if you want to send keep alive, then you can use the idle timeout, and you should send it earlier than the idle timeout, right? But I think that's not the complicated part. The other one is like, do we want to really require everybody to send like keep alives on a path, or can we just keep?
No, we never want to require people to send keep alive. Never. Yeah. It's never a requirement. Yeah. We know that people will do that.
Yes,
some people will do that. And the question is, if, for example, they will do that, they have to do it in a useful way. And to do that in a useful way, they have to have an idea of how long the peer is waiting. So by default, we are going to say, what we have in the doc today is say, oh, how long the peer is waiting shall never be less than the idle timeout that you have published for the whole connection.
Yeah. So until the idle timeout, you can be sure the other one shouldn't just close it.
So basically, if you tune something, you base that on the global timer.
Yeah.
And I think that's okay. And I think that we don't need the complexity to say, oh, that particular pass, I'll close it after 10 seconds if you don't tell me the other one. I don't think that we need pass-specific information.
No.
But that was the only thing that was still open, in fact.
I wouldn't say so. The other thing that's still open is, can I, if the idle time was expired, I didn't send any keep alives, and I didn't get an abandoned frame, can I still use the path? And I think the answer is yes.
Yeah, if you have not received a path abandon from the peer, you can use the path. That's unambiguous.
Okay. So I think we have to remove the sentence and maybe provide more explanation to make things crystal clear. Yes. Okay. And I don't think actually we need any normative language here, because that's just the way it works. Okay.
Hey, so I'm coming at this from just a familiarity with idle idle close on normal quick. I'm finding this all rather confusing. Like it seems that you have one set of rules for one thing and a completely different set for paths. And what I like the silent close feature. I like the ability to, after a well-coordinated fixed point in time, to blow away state, regardless of which pair I am. I think that's a benefit of Quic compared to other transport protocols. Like what I'm hearing here is like, oh, it's not. You can kind of set this value and it doesn't mean anything. Maybe I'm misunderstanding. I'm remote and I'm not well. But like, yeah, I'm going to take a look at this issue. It might have comments that don't necessarily reflect what was being discussed just now.
So if I understood you correctly, the difference here is that we say you always have to send an explicit signal. So if you want to close the path, there should never be this case where you're like not sure if the path is there or not, because you always have another active path. So it's always better to be explicit about closing a path. And therefore, you actually don't need to just like close the path on an idle timeout and have some guesswork, because you will tell the other end if you close a path. And that's different if you close a connection or if you idle out a connection, because when you idle out a connection, you don't have a communication to the other end anymore to tell them about it.
Maybe, but it makes me wonder if you could keep a path alive by sending a signal on a different path. If you want to avoid keep alives on that path. So again, I'll
Okay.
take it to the issue.
Interesting. Seems also a little bit like overhead to me, but we can think about it, yes.
Yeah. Martin Thompson, I think what Christian suggested here is the only sensible thing to do. The idle timeout is about the connection state, not about the path state. And you have explicit means to signal path state, use them. I think that's a reasonable conclusion here. Using idle timeout to mean something else is, I think, an abuse of that mechanism. The idle timeout says, if I don't hear from you for this long, I'm no longer there. It's a connection level thing. The path keep alives and whatnot are entirely independent of that, and overloading that, I think, was a mistake.
Yes.
Also, that sentence doesn't make sense to me. So,
yep.
Double win.
I agree. That's actually a good point.
Yes, Kenji. For this one, for the idle timeout part, well, I think Mia, you mentioned about like mobile service scenario here, because the mobile UE equipment want to lower consumption of power always. So every sometime, if the activity is low or does not want to receive anything, going to put itself in some specific mode called RC inactive. So if we use the keep alive for this type of things, that means every sometime the mobile system, the core network has to page the UE to force it to do something actually does not want. So, my suggestion here is like using the idle timeout, but now the keep alive, those type of things. But I don't know what type of, the number, like the keep, to use here, but it's just the suggestion from the mobile world. We got this type of, we try to avoid the situation to be paged, every sometime. So thank you.
Yes.
Corey, I think Martin might have said something that was useful. I think there's maybe a slight mix-up between whether the remote endpoint is alive and whether you want to keep the path active for some reason. And I think these need to be separated clearly. And the path thing, maybe you have local clue about whether you want to do it or not. So that's kind of dependent on the path.
Yeah.
And if we drill there, I think we'll find an answer.
Yeah. Okay. Okay, last issue. So we actually, when you send, when you open a new path, means you're sending a packet with using a connection ID that belongs to your new path ID. So you can like clearly identify now with the explicit path ID that this is like a new path that you want to open. And we actually say you have to send a path challenge within that packet. So it's not like, because like previously in the migration case, when you have a net rebinding or whatever, it can always happen that you get like packets which are kind of opening new paths but weren't intended to. But here, With path, explicit path ID, we don't have this case. We always kind of explicitly open a new path, and there has to be a path challenge. It's a must. But we don't say anything what happens if you receive a packet which has a connection ID belonging to an unused path ID that doesn't have a path challenge. So we have to define that. And there are three options here. Either you just like say, okay, whatever, I still want to open the path and I send you a path challenge, or you just ignore the packet completely because it seems wrong, or you actually do a connection error and close the connection.
Kazuhoku, I prefer allowing this behavior because unless we do, it will require the endpoint to include path challenge for all the packets that it sends in the first flight. And that's going to be a huge burden.
So, but it could then also be ignored, right? So you just ignore it and then it might arrive later and then you have to retransmit that packet.
Yeah, I mean, like, assuming that they are dropped, I prefer doing as much as we can to rescue them.
Okay.
Rather than dropping.
But also keep in mind, it's like you open a second path somewhere, right? So you might have an active path where you can send all your data, and only when the path is open, you maybe want to send your data there. I don't know.
So the purpose of path challenge is for the sender of the challenge to be able to validate that the receiver is able to receive. It is, I think, inappropriate for us to be requiring particular behavior on the other end of that. So yes, while there may be cases where a sender sends with connection IDs or whatever that shouldn't be sent, that's not the business of the receiver to police that. They've made that path ID available on that path, and I would suggest that you don't have any requirements around these things.
So, but that means this is
So
solution A, because you want to validate the path before you use it. So if you receive something on a path that doesn't have a path challenge, you have to initiate a path challenge in order to use the path.
That's right. So this is a requirement on the sender on that path to do all of these things, but I don't think having an enforcement on the other side is appropriate.
So it's okay. You either send a path challenge or you don't do, or you like, I guess you still ignore the parse.
The expectation is that someone who's attempting to use a new path will challenge on it, use the appropriate path IDs, use the appropriate connection IDs for that path, all of those things. But the person, the endpoint receiving all of that, its peer, there's no, it does not owe an obligation to check that the other side has correct. It's not responsible for policing what the other side does in this case, because these are not there for its benefit. It's there for the.
I understand what you're saying, but I don't know what it means in practice. So you get a bunch of packets from a new path that have not been validated. Should you accept and process them or not?
So validation applies to the thing that's sending, not to the thing that's receiving. So if the packets are valid, accept them.
Okay.
Yeah, pretty much what Martin says. I mean, oh, excuse me, it's Mike's turn. Sorry, Mike.
Also echoing what Martin said, both sides are required to do path validation when a new path opens up. This is the same as with migration to a new path in RFC 9000. The fact that the client has not validated it yet does not absolve the server of doing its own validation, and the server is not responsible for checking that the client does path validation. There might be the same anti-amplification requirements on a new path that would apply to the server if it sees these packets come in, but that's true regardless of whether the client does the path challenge. I think the text here would just be, when you see packets on a new path, you must initiate validation, and there's no requirement to check that the peer did it.
Yeah, so exactly. So that's what I wanted to confirm. So we have a must here. We keep a must, but we don't enforce it effectively.
It's really a should. No, it really is a should. It's not a must. Should not be a must.
So you actually want to change it to should.
Yes.
Okay.
Yeah, because I mean, you cannot. The must will be to force the peer to do a handshake before using packet on a new path, and we do not want to do that.
So there is one exception, which is if you use the path, the same tuple recently, then you can skip it. Just to. That's already there, but it's a very explicit exception.
Yeah, we have now 9,000 is more restrictive because 9,000 has a lot of concern about using only one pass at a time. And that concern about using only one pass at a time drive a lot of restrictions. In our case, first, I receive a packet from you on pass 9, which I have not used before, and that packet is good. I mean, it's using a CID that is legit, and the checksum validates. Of course, I'm going to use it.
Yep.
Of course, I'm going to accept it. That's not a protocol error.
Okay.
I don't know what's happening with your. Maybe you decided that basically you know from other places that that path is perfectly good.
Yep.
And so you don't actually need to check continuity. That maybe, I mean, that's.
Okay. No, but then it sounds like this should be a must. It
That-
should
that-
be
that
should,
should-
sorry.
that is a should. That one is a should
Yes,
be a
okay.
should.
Okay, yeah.
Because, I mean, you may know that the path
Yeah.
is perfectly good by other means.
Yep.
Yeah.
Watson Lad, Akamai, I'm a little confused by what the intended scope of the validation is. So let's say I have a client, it has two possible addresses it can send from, but it's connecting to a server with one address. Does it need to validate that address twice? Is that a choice the server necessarily should be enforcing? So I'm leaning towards what other people are saying, which is if you get a packet, it's up to you what validation the side that receives that packet does before sending. But they shouldn't expect to know why the other side made the decision it did. And so there shouldn't be any need for rejecting a packet because you think the other side shouldn't have validated it.
Yep. Christian, you were already in the queue, right? Okay, yeah. Kevin?
Yeah, it's my understanding that if you receive a valid encrypted signed packet, you can use it. There's no reason not to use it. I think validation is just you shouldn't send unless you know that path is good for DOS problems, basically, right? That's the main concern. So yeah, like if you receive a packet, I just see no reason not to use it.
Okay, makes sense. Martin?
Martin Duke, Google. Like on the should must thing, it feels like this is, well, so I agree that it should not be enforced, but we do have in Quic other musts that are not enforced, like the, connection ID unlinkability thing, because it's just something you really should do is adjust the, validate the address. And like, I'm fine with like must unless all these conditions, but I can't think of a case where the address has not been validated where it is like reasonable to not validate it. And so like, unless the should has reasons why you might not do it, I think we should make it a must, even though it's not enforceable.
Then we get into interesting territory. I think the problem here is that this requirement is specified very, very precisely. It says you must perform address validation with path challenge. And I think what we say in a lot of places in RFC 9000 is that you must validate that the peer is willing to accept the packets you're sending. And it doesn't necessarily specify precisely how you do that. And it might be that you've recently checked or you have out-of-band information that gives you that. And so if we change this to simply refer to section 8.2 of Quick Transport and say that you must validate the path before you send on it, I think we avoid a lot of these sort of really fuzzy bits, and we leave it open to the shoulds by virtue of the fuzziness that's in 9000.
So I would be in favor of, yes, must validate the address in accordance with 8.2 or whatever of 9000,
yeah.
and
without the specificity.
And yet there's no enforcement, and I think that's okay.
So
That's right.
In this case, I wonder if because I don't want to repeat normative language from RFC 9000, so maybe we can just not use normative language and refer to RFC 9000 because the requirement is already there.
I think this is important enough that we should have a must here that's independent of what's in 9000. But for the most part, just refer to the procedures that are in 9000 for path validation.
Christian.
Let's be clear. The reason we validate the path is because we don't know that it works. That's the main reason. The other reason is we don't know that the peer has the resource to accept a new path in the protocol. Now, with the multipath extension, we do know that the peer has the resource because otherwise they would not have sent the connection ID with the path number. So the only test that we're doing is verifying that it works. So you receive something, it's because the peer has convinced themselves that they can send on that path for whatever reason. It may be that they have checked BGP. What do you know? Okay. The packet did arrive. That's cool. That doesn't mean that you should immediately start sending responses on that path, because doing so would open the gate for all kinds of denial of service attacks. So you must verify that the path works before sending, yes. Okay. And in fact, I really think it's a should, but the reason I think we should write should is that I disagree with the notion of having must that really means you must do it, but we know you won't. I mean, there is an all RFC for alternative must and should, and we're not using it. So if must means also that the peer shall enforce it, and we don't want the peer to enforce it, so that means that we shall not use the must verb, but the should verb.
I mean, I'm with you, but apparently that's not how we did it in Quic in some cases, so I don't think it makes a difference here.
Well, I said my piece.
Yes.
Gori, I think I'm confused again.
Okay.
Are we validating that the server is the server we're talking to, like we were in Quic? Or are we validating that the path has connectivity? Because one of these is a security problem, and one of these kind of looks like a connectivity problem. I mean,
no,
have I muddled this up?
No, we're validating that we have connectivity to the server we actually want to talk to. It's not only about pinging the path.
Right, but the big thing about Path Challenger was to kind of figure out we're talking to the right server, and that was good. But I mean, we're talking to the same server on a different path. Is that, I mean, have we somehow conflated two things, or I just got really confused?
I don't think so, because you also, I mean, just because you're receiving the packet, it's encrypted, you can decrypt it and make sense. You already have, you know that like this belongs to the same connection. Yeah. And then the only piece is missing, that you also need a reply from the server to understand that this actually happened. So that's what we're validating, that the server can reply to you.
So we're just validating connectivity here.
If you want to define it this way, yes.
Okay, that helps. Thank you.
I think that was the last issue, and we're over time.
Yes, but thank you for the discussion. That seems like it's very productive, and you have everything you want, probably.
Yes.
Yeah.
Thank you very much.
All right. So we're going to now move on to discussing the work going on with the QLog documents. Lucas, do you want to do the slides, or are you just going to say next?
I'll say next.
All right.
So everyone, yeah, this is QLog, the one without Robin. Robin's on holiday, so I'll be doing a job. I came out with COVID, so I haven't been able to do as much as I would have liked to. So this is going to be shorter than we originally had. So hopefully we'll be able to catch up on some time. Next slide, please. Since the last time round, we've updated the documents. These are the latest versions. We posted an update to the list, but really this has just been focused on well-defined extensibility of the events and schema along with more use of media types. So we want to register them. What I mean there is we're already using media types. If you were to use like HTTP to request a QLog or to upload one, we would have that in the content type field. But if you go to the next slide, please, Matt, we decided to use media types in the serialization format field as well, which is the second one down there. In the past, we had a value in there that was not a media type, it was something else, which raised the question about whether we needed a registry of format strings or whatever. And so as part of all of this work, we've decided just to reuse something we're already using. That's an open question I've got for people. If they think that's a bad idea, I'd love to hear why, and I'd love to hear that now because we have a chance to change it. But modulo that's what we'll be going forward with. Just to walk through some of these other fields in bolded values. As an example, this is a QLog file that would be using the contain format, the thing where all of the events belong to a single, well, all of the traces and therefore the events in a trace belong to a single file, and they're structured in a contain format, has this new URI that would define them. And because this is an Ietf standard, we would use a URN of this format. Similarly, for event schemas, this is a new concept that we've had. We discussed this last time around and ad nauseum, but we iterated a lot on the tickets and in the PRs within the editors group and landed on this design. I don't want to waste time going into it in detail. It's all in the document. But effectively, we have this idea of a events namespace, and then following from that, other namespaces. I just realized there's a typo on there, sorry. But then categories of events, and specifically for the process we're in now, where we're iterating on those event definitions, and you might have a QLog file that has events from one version or the other. Being able to include a versioning within that is useful and helps solve a lot of the versioning problems that we've been tracking as issues for a long time. So with all of this, we've closed out basically all of the major blocking issues that we have. And if you go on to the next slide, please. We thought we were done, and then kind of the next day that we merged this and I started to work on an implementation of it, I realized that there's one more edge case we hadn't covered quite. So there's an open issue. The example here is that if you have something like a packet sent event for Quic, and you just want to add a single field to it, you just want to add a field. But the way to do that currently within the whole namespacing thing that we came up with is you'd have to redefine the event entirely in a new namespace and a category and a new event name to avoid any naming collisions with things. And that's a lot of work, and that's pretty terrible and counter to the extensibility design that we had in mind. So the proposal is just to add another form of prefix for these things that will have like an event extension thing, and you define the extensions that you have, and then obviously you could go off and read the spec or wherever they're defined and find out what those things are. Watson's asking in the chat, are we sure we didn't want to use XML? Yes, I'm 100% sure I don't want to use XML. But yeah, if anyone's got opinions on that, this is kind of the follow-on last big issue to the last big issue that we had. Next slide, please. One of the only remaining ones that personally I have is the problem with clocks that we presented back in Yokohama. It's exactly the same problem, effectively. I came up with a pull request at the time, and we decided that actually that wasn't the way we wanted to go. It added a lot of confusion to other folks who didn't necessarily grok this problem the same way as me. And I think that was fine and that was good feedback. So we'll want to go with something simpler. And if anyone feels strongly about clocks, I'd love to hear now, or to comment on the issue or the pull request that there is. Let's see Watson in the queue.
Watson Ladd, Akamai, we've already got a ton of stuff from this in NTP. Use UTC timestamps. That's what you're supposed to do for interchange between systems. I understand there's complications with doing that, but there's a reason why that's sort of the best solution.
So I appreciate the comment there. I would say from an implementer perspective, we only care about relative times of events, and we don't want those events to have clock drift effects. And so internally, for our things like packet timings and pacings and everything, we use monotonic clocks. Same for our server applications. We don't care about interchange necessarily. Even in tooling like QViz or some of the stuff I've written, I only care about the relative timing from the start of a connection. So converting those things is in some ways impossible. You can fudge it and come up with things, but there's always going to be edge cases that are introduced. Requiring to log in some form of timestamp is hard if you're on a platform that doesn't actually measure timestamps in, say, Unix, for example, and needing fully qualified UTC timestamps is going to cause verboseness in logging. So you'd be looking at a compression mechanism, of which we do have some. But effectively, what we have in QLog right now is a lot of flexibility to allow people to do what they like to do. And that causes some kinds of annoyance or interrupt. But yeah, Watson, if you would care to comment on the issue, maybe with some perspectives, I would love to hear them and consider them.
Will do.
Thank you.
So I think this is a lot easier for those people who are managing devices that sometimes get things failing across, for instance, clock corrections and various other things. It's much easier to debug with a monotonic clock, and you get much more reliable logs at that point. It's my opinion that we should have an epoch in the file that has an 8601 format timestamp or the RSC 3339 format, whatever. And then all of the times the individual events are sort of millisecond offsets or something like that from that point. That's a lot easier for, my understanding, a lot easier for most of the implementations as well, because they all tend to use monotonic clocks simply because they don't want to be exposed to the vagaries of wall clock time.
Okay, but to respond to that, like the epoch of my monotonic clock is whatever my system decides when it comes up. It's like we put that, it's an opaque value that no one else can ever know effectively or doesn't care to know.
Right.
I can grab a current time in some format, but the millisecond offset from that isn't. My worry is it's confusing because people will think they can always restore the time delta to come up with an absolute time that's correct, and then use that to go and look in some other system, and that won't be right if there is some form of clock drift or something.
Right. So the monotonic clock won't necessarily advance at the same rate that everyone else's monotonic clocks advance, but there's a general understanding that 1 millisecond is approximately 1 millisecond in all of these cases. What I'm suggesting is that time zero is established by looking at the wall clock and looking at the monotonic clock and establishing a reference point. And then from that point onwards, the delta to that reference point in the monotonic clock is what you use for the logs. That's what we do.
That's fine until you hit something like daylight savings where you go back an hour and you're trying to correlate a Q log.
No, I'm suggesting that what you have in the Q log then is this connection started at this time, which is the wall clock time, and a time zone, probably in UTC, probably not UT1, logged in the file. And I think most people, as Watson pointed out, most people will be able to turn that into something that makes sense for them. Then all the events are relative to that time in some sort of absolute reference frame. And maybe that's not 100% perfect, in the sense that your monotonic clock might not be precisely the same as my monotonic clock from that point onwards, but it's going to be close enough for most purposes.
I 100% agree, but my only concern is that people will maybe say, process that Qlog and enrich it so that it goes back to every event has a wall clock time, and that's kind of fine. And then they'll want to correlate that to other logging systems that use wall clock times, and that the monotonic clock didn't actually follow any wall clock time, and that you get weirdness with time zones or changes, and there can be errors. I don't think that's a huge problem. I think we can document it, but I just want to avoid a bit of a foot gun there.
That's a problem for those performing those translations. Once they decide to do that, that's something on their shoulders.
Cool. Kevin?
Yeah, I agree. You can only stop people from shooting themselves in the foot so much. I think like I can see future extensions where you add other reference points to link the two, but I think for starting, like, yeah, let's just add one reference at the start. And if it ever becomes a real problem, we can consider other things.
Okay, cool. These comments echo stuff I've heard from other people internally too, that they would really like something, even if it is potentially wrong. So yeah, I can take that away and come up with an answer, or sorry, a proposal to bring back to the list. Could we go on to the next slide, please, Matt? And so yeah, looking ahead. We have a planned update for QViz. I say we, I mean Robin is going to do a lot of the work there. So now is the time to start thinking about updating to the latest drafts. I know in the past, because Qlog is kind of not that useful unless you've written your own tooling, and not many people have, and they rely heavily on QViz, and it's been lagging behind. There's kind of this chicken and egg problem. But Robin's announced that he has these plans for August and September, and I would suggest we all start thinking about updating. I did this for Cloudflare's Qlog implementation, and it took me just a couple of hours, just renaming events here and there and moving stuff around a little bit. And I took a pass at making sure my events were actually still up to date. I dropped a few fields here and there over the years too, so it's really not that much effort. On the spec perspective, we only have 25 issues remaining now, and all of those have been raised by the document authors as we continue to go through. Many are editorial, some are kind of open questions. None of those seem huge, but that I want to identify that that's coming from the author group. So I have a polite request for people to please consider reviewing and implementing the spec if you haven't for a while, because I would love to be able to come back at Dublin with more slides of substantial issues that we need discussion and face-to-face time, or the opposite case in that we're just ready for working group last call and we can do that and maybe come back with some final questions or comments at Dublin. So yeah, that's all I have. Thank you.
Thank you, Lucas. And before we go on to our other items, I believe our AD would like to ask a question about multipath.
Jahed. So I think today I saw really good progress on MP Quic issues, and my understanding is most of the design related issues out there was kind of resolved. So I'd like to get a sense okay, how far we are from completing this task. Is it 2 more Ietf meetings or 2 more revisions? Is there any plan? Authors can tell us more about what they think, or the chairs can update me on that.
Mireya, you want to start?
Yeah, trying to join the queue. There I am. So yeah, we went through all the design issues. All the remaining open issues that we didn't discuss today are editorial. So hopefully that's kind of actually the last set of design issues that we have. I think we need quite some editorial work, so probably it's more than one update to the draft. But if new design issues come up, I would actually like to go for an interim or whatever, so we can actually kind of conclude by the next meeting, more or less.
What is your sense on the state of interoperability and implementation status? Do you think that's equally good as the design issues, or are they?
So there is multiple implementations that interrupt. They are not interrupting under all the tests that we have, so there's still a little bit something to do, but I think we can also get there by the next meeting. Especially the one thing that we just added newly to our test is because now you have actually the path ID, you can also migrate on the same path. So we're testing this as well now, which didn't work everywhere. But I think like with those tests, we actually can be at a state next time where it works.
Yeah, I think that sounds really good to me. Yeah, there are a couple of things like here would be really good to see on testing, like if you get a packet on an invalidated path or like a not validated path, then how do you handle those kind of things? Like we discussed today, like we don't care, but it would be good to get some interrupt testing. So you talked about interim. You were talking about like the interim from the next Ietf meeting or potential interim? Or,
yeah, so if we get into more issues, that would be my preference to have an
Okay.
interim before the next.
Okay, thank you. That gives me some idea. Thank you.
Just a clarifying question: do you mean virtual interim or physical?
Virtual.
Thank you.
Okay, next we have, we're entering our as time permits. I assume, Martin, this is you. So we're going to talk about accurate ECN acknowledgements.
Oh.
Yeah, someone is in the queue.
Hi, Francisco Mrakif. On the previous point, I wanted to quickly mention, as an observer, what I feel is missing in the multipath Quic. I don't see a lot of diagrams. I don't see a clear definition on prioritization, scheduling. So is that in plan? No?
Diagrams and tooling, is that what the question is about?
Yeah, diagrams would be
Schedulers.
nice. I'm sorry?
I believe scheduling is explicitly out of scope for this working group. This is more about the protocol mechanism, and scheduling is a different task. As to, in terms of diagrams, I think the authors would be willing to entertain diagrams as appropriate, but I don't believe there's any planned work on that front to change right now. Martin.
Hello. So I'm here to present a new draft that I submitted together with Vicky from Apple. Next slide. So the purpose of this draft is to make ECN acknowledgements more useful in Quic, more fine-grained. So let's take a look at what we have in RFC 9000. We have the ACK frame, which encodes the largest acknowledged packet, some delays, ACK ranges, and then we have ECN counts. And these ECN counts are just 3 numbers for the ECT0, ECT1, and the ECNCE packets. And that's the total count of packets that was received with these respective markings. So when you receive an ACK frame, it could acknowledge, let's say, 100 packets at a time. And as a receiver of the ACK frame, I know what the ECN counts were before. I know the new ECN counts, so now I can figure out, oh, there were like 90 packets with ECT0, and there were 10 packets with CE. What I don't know is which of these 100 packets were CE marked. And what this extension is introducing is a new encoding of the ACK frame that allows me to learn exactly this information. Next slide. So instead of just encoding the ACK range with the number of packets that were received as in RFC 9000, we now add an ECN marking to an ACK range. So now I can say packet numbers 500 to 600 had this ECN marking, and packets numbers 600 to 605 had a different ECN marking, and I just put these in the ACK frame instead of the ACK range that RFC 9000 defines. So this allows the receiver to know which packet was received with which ECN marking. Why is this useful? If you want to use L4S and a congestion controller like Prague, when you look at the equations, how to modify your congestion window, the thing that goes into the equation is the size of the CE marked packet. So by knowing which packet number it was, you know exactly what size of what the size of the packet was that you sent, and which packet number was CE marked, because there's an additive increase and a multiplicative decrease, and so the order in which you apply those has an effect on the congestion window.
Hi, Lars Eckert. You answered my first question, is what is good for, which is L4S. Have you looked into how much more the ACK frame would grow if you did this? Because now you're creating ranges when the ECN bit pattern changes and not the loss pattern changes, and there might be a lot more changes.
Yeah, that depends very much on how the markings are applied. We are still encoding ranges, right? And the expectation is that they're
every flip in the bit pattern causes a new range. So,
yes.
So 2 variants and 1 8-bit. So I just wonder, like, if for any like ECN like drop tail, red Q or even L4S, whether you had done an experiment that like said something about the sizes you saw.
So for L4S, you expect 2 marked packets per round trip time, right? So this is creating a few more ranges, but not a lot.
Gori, I'm not sure. I mean, when we there was a little design team kind of thought about this before we did it. It wasn't random. And we wondered what happens when every other packet has an ECM mark, just because that's the way it is. I mean, like, we don't know how these patterns of ECM markings will actually play out. So adding a data structure around that and expecting it to be populated looks like a dangerous explosion in the size of the packet. I'm also not entirely sure, knowing the size of the packet that was CE marked actually tells you that much. It tells you that packet was marked in the queue. But I mean, do you want to base decisions on that, or do you want to base it on the sizes of packets you were sending at that time, including the ones which weren't CE marked? So I'm not sure the extra information helps, but maybe you have a way of using it that does help. So I was trying to bubble up and ask, why does the size matter?
Okay, so to your first point, every packet having a different ECN mark, that's the worst case scenario, right? Like that leads to the largest frame size in this encoding. I don't think it's very realistic to have an on-off pattern there. Regarding your second question, why does the size matter? This is what the proc congestion controller does and takes as input. I am not sure why it's using the packet size there.
The average size that we're sending, or the size of the particular CE marked segment?
No, it is using the size of the particular packet that was CE marked.
Okay, we can think about that one.
So a couple of points. First of all, for the TCP proc, that's also kind of more on the wish list, right? In TCP, you may or may not have this information, so you have exactly the same situation. This is not a new use case. L4S and TCP proc is exactly what we discussed when we designed the initial ACK frame, and we decided this is good enough. So I don't think anything changed here. So I'm not sure we have to change something here. There's like a whole long discussion on the issue that you might know. And on that issue, there were also different proposals how to, if you want to have more information, how to design it. And so you took the most complicated one or the most rich one, because you can now exactly see which packet had which markings. The other one that would be much more easier would just be, instead of having a packet counter, having a byte counter, because you don't need to know which packet, just how many bytes, right? So if that's kind of your problem, that would be the good solution. But even that part, I don't think it's needed. Just take the average sending side and you will be good enough. If you want to experiment with something more accurate, you can also, with the current ACK scheme, just like ACK every marked packet separately, and you get exactly the same information, if you have control of the other end, of course. But for an experiment, that would be good enough.
Yeah, so what we currently have is not good enough to implement, because I tried implementing proc, and I was running into exactly these problems.
So why don't you just use the average sending
size? No,
size?
I can use the average sending size, but this still doesn't resolve the problem in which order to apply the increase and the decrease.
the order you're applying it.
Yes, because for every acknowledged packet, your congestion window grows a tiny bit, right? And for every CE mark packet, your congestion window shrinks by a multiplicative factor. So if I do the addition first and then the multiplication, is a different outcome than doing the multiplication first and then the addition.
But does it matter? Does it actually change the performance?
The congestion window will be different.
Yes.
I have no measurements how much of a difference this makes performance-wise in the real world.
So that's the question we need to answer.
So please tell me that a gap can be 0 length.
Yes, it can.
So you change the format of the ACK. So I think stepping back a little bit, independent of the details of implementing Prague or BBR or any of these things, what we're seeing is the use of ECN markings to carry information. And if that information were maximally useful or maximal for maximum surprisal from an information theoretic perspective, they would effectively be random from the perspective of the sender of the packets, the one that's receiving the ACKs. And so if you're looking to build a system that gives you information on the markings on every single packet, the ideal one would be one that's suited to encoding what is effectively random information coming out. And this sort of run length encoding is very inefficient when you talk about random information like that. So I suspect that this is not quite fit for purpose in the general sense that you're looking for.
Christian,
Magnus is before you, Chris.
Yeah, actually, so I will tell you how it's done in the mobile system, the L4S or ECN marking. That's backfeeding a marking percentile, which is then applied to not the packets that actually resulted in the queue, unfortunately. And this is how it's done in 5G for a moment. That can't be fixed until future, maybe in 6G. So you're anyway just getting a random application of a marking ratio. So it's not accurate to the level anyway on the specific packets, which caused this. So it's I think you will have to figure out. I think is this really relevant to change do this for now, or is it enough to basically saying, oh, if you're going to implement it, what's the over this time? Oh, I have this many CE marked packets that made me, and then just randomize a sequence that fulfills that marking percentage, and see if that doesn't work well enough. But yeah, if this, I think, if it actually is a problem, yes, we should do something. But I am unconvinced for a moment that this is a significant issue.
Okay, so I have a couple of issues there. First, I mean, as Martin said, in the average case, the range will be quite short, because if you are applying random marking, by definition, the range will be very short. So you are going to have a large size of the ACK. Moreover, if you have an adversary on the path, then you have opened the way for that adversary to mark every other packet and blow your ACK size. So you have a security issue there. Second, so that I think that there is a cost, okay? Second, if you are going to do that, I object to doing that just for ECN. If we were to do additional data on the ACK range, then we want to have the delay as well. And if we open that kind of worm, we want information about the transmission delay, because the transmission delay gives you as much information, if not more, than the ECN marks.
Are you talking about your one-way delay extension?
Not necessarily the one-way delay extension. We already have a delay in the ACK that applies to the latest packet. What you want there is to have a delay for the range.
Yeah, there's a draft floating around that does something similar with timestamps.
So if we do that, we need to have something like that too.
Sure.
Okay.
We can do that.
And the first thing is that I don't think that Prague is the right motivation to do that. I think that Prague is making assumption because they want to do proportional feedback. But as Magnus was saying, the marking, the actual marking implemented in the router is not necessarily based on the length of the packet. It's largely based on the order of the packets. So I think that what you really have is that you have a statistical expression that allows you to compute the rate of marking. And it's a rate of marking per packet. In fact, the routers are not marking per byte, they're marking per packet. So what is to be done really is to work on Prague based on the reality of what the marking is. And if you accept that the rate of marking is marked per packet, not per byte, then you have to basically see how you deal with that inside the Prague stuff. And they probably have to revise their algorithms a little bit to take into account reality and not force a complicated change in the structure just because of that. Finally, if you want to have something accurate, what we can work with is the arc frequency. Because really what we want is to see that if there is a change in the marking rate, then you want to inform the other peer quickly. So basically, I think that to make Prague work, the thing we really want probably is first to work on the arc frequency modification to make sure that the arc frequency are also triggered by the change in marking. And that probably will be more productive.
Okay, so I'm going to jump in here as chair. It sounds like there's a lot of interesting discussion here. We're not going to run a poll or anything on this, but I think this is probably worth discussing offline amongst the authors and also the people that had strong opinions about this. It would also be great if this could be reflected on the list, because I think this topic has come up on the list to no response, which is not ideal. So if you could maybe follow up NVIDIA as well. I'm sorry I dropped you, but Lars, what do you want to say?
I want to suggest that we experiment with the Quic extension, because you can do this with another frame type, and then you can try it with L4S, and you can tell us whether it works.
Yeah, so if you in that kind of data and then reflecting on the list would be great. So yeah, cool. So we have a couple minutes. We just wanted to give a quick final thing, which is
yeah, with regards to time, maybe we can skip this and give the 2 minutes to Mike. I've done this presentation already twice at ANRW, so if people are interested in prioritization, I would just suggest to go to the ANRW recording.
All right.
We have also a nice paper on the ANRW website, so it's maybe a better idea in scope of time. Thank you.
Thank you. All right, Mike.
All right, thank you very much. Can you skip slide? Since I don't seem to have control.
It's not. Let's see if I can do it. You can just start talking too.
Okay, so if you can go to the next slide. So in RFC 9000, we have this assertion that tokens provided with new token frames and retry packets can be distinguished by servers. If you go one more slide, that comes from a requirement on the construction of the tokens that the server must make the tokens in a way that it can tell them apart. And because of that assertion that we can distinguish them, we can be stricter on retry tokens than we are on new token tokens, because the client's address might have changed. The new token one is old. It might not be valid anymore. Let's skip forward 2 slides. Okay, so the problem comes up here when the client gets a new token back from one server at a given name, and it tries to use that token in an initial packet starting connection with a different server that can't read that token. Because they're coming from different servers, one server's new token might look like another server's retry token. From the server's perspective, it just got a retry token that doesn't parse, and so it closes the connection with an invalid token. So this is something where the server is doing the correct thing according to the spec, and it is breaking client connections. Next slide. So the reason for that is because we wrote the spec assuming that the token was only being read by the entity that generated it. But in the multi-CDN case, one CDN's tokens can accidentally get sent to a different CDN because the client doesn't know any better. So this is kind of making me wish that we'd included a bit in the packet that said whether it was a new token or a reset token. But the other way you can handle this, most implementations are doing some kind of cryptography to check that it's valid. We could just shift the definition of when it is an invalid token to say if it is valid, it came from you, but it doesn't match the client's address, then is when you kill the connection. So I filed an erratum on this. We might want to add that bit in Quic v3, but this is just something that has come up, and I know at least some implementations have fixed this, but it's something to be aware of. Do we want to do anything about this, or just leave it for the next version of the document?
Martin.
So if Martin Duke, Google. So if I understand correctly, multi-CDN does not result, when you go to a different CDN, it does not result in a different IP address. Or rather, it does result in a different IP address. And like, if I was a client, I would not go to a different IP with a token from the previous IP and expect it to work.
Well, so the issue is you can include it, because it's a new token, you can include it, and whether it works or not, the connection shouldn't fail. The problem is that here the connection does fail if the server follows the RFC.
Q.
Q Mycel, MPI Inf. I'm not sure if you've seen my small amount of posting on the list a few months ago about extensible tokens, but I think that would also serve as a way to solve this. I guess, what are your opinions on doing that instead of just defining a tiny bit or defining slightly more, so we can solve problems like this in future?
So yeah, so having a token that you know is of a particular structure, and then you can identify what the purpose is.
Yeah.
That would give you a solution to this, so long as you first are able to check that the token you received conforms to that format.
Right. Yeah. I guess this is not the right place to discuss it. We'll discuss it on the list, but I think that is an option, and I'm proposing that we look into it.
Yeah, that would make this a smaller problem.
And Kazuhawk, 2 points. First, this is a real issue for multi-CDN if mask is involved, because mask servers do the address resolution. So the token could go to CDN A and then to CDN B. And then the second point is that, if I recall correctly, we design tokens based on how we design session tickets in TLS. So we kind of implicitly believe that they would have an AED tag or whatever for verification, and if they don't match, we reject it. So I think that's the design that we intended. So if there's something vague in the spec, I think it's simply an under specification.
Right. So the erratum that I submitted suggested that if it is cryptographically valid, but for the wrong address, reject it. If it's cryptographically invalid, ignore it.
Okay, and I think with that, we are, that concludes we're over time, so that concludes the meeting. Thank you everyone for participating. A special thanks to our note takers, Martin and Marco, and we will see you all in Dublin and on the list.